Right, let's see if we can get going here. Uh, Morning, if it's morning for you. Welcome to the stream, just letting everything load up. Today we'll be going over section 4.3, which is actually a pretty decently long section. In the previous sections, we've gone through basically how to do class relationships with has a and part of relationships. So today we're actually going to be exploring the best practices in managing relationships between classes. So in the previous sections, we learned about two fundamental ways that classes can relate to each other through has-a relationships, where one class contains another as a member, and through is-a relationships, where one class inherits from another. We'll look at how to design and manage these class relationships effectively. We're going to explore crucial concepts like coupling, which is how tightly classes are depend on one another, and the principle of most restrictive access, which is how to control which parts of our classes are visible to others. We'll also learn about the single responsibility principle, which helps us create focused, maintainable classes, and discuss technical debt, the long-term consequences of our design decisions. These principles and practices aren't just theoretical. We'll be seeing them in actual practice. They're practical tools that can help us create better software. Whether you're like building a game, which I tend to do, or you're doing a business application, which most in industry do, and any other type of software, understanding these concepts are going to help you create systems that are easier to understand, modify, and maintain. Now, throughout this presentation, we'll be using real-world examples to illustrate these concepts, showing you what the principles are. Gotta turn the ads off. Let me see if I can. I might not be able to while it's active, but let me try. Let me try. I tend to do that. Give me one sec. Yeah, let's see. There we go. All right, this should be off. Ads should be off. I tend to turn those off whenever I need to, or when I try to turn them off for all educational content for sure. But let me go back to my stream manager just to make sure if that works. Okay, so does the ads? I think the ads should be off at this point, so that should be all right. Yeah, you shouldn't see any. I tend to turn those completely off during education. I'm not sure why they were on. Maybe because I did a Resident Evil stream yesterday or something like that. But yeah, they should be off. Ever since I became an affiliate, they tend to go on by, yeah, by default. So I have to like go in and manually turn them off. But nonetheless, should be good. Okay, so throughout this presentation, we're going to be using real-world examples to illustrate the concepts, showing what the principles are, why they matter, and how to apply them to your own code. So let's begin by understanding coupling and how it affects our class relationships. If I can, I have to switch over to monitor. There we go. Okay, so let's see if we can get there. So let's start by understanding coupling, which is a fundamental concept in managing class relationships. So coupling actually measures how much one class depends on another. Um, in other words, how much one class needs to know about another to do its job. Think about friendships in real life. Some friends know everything about each other. They know each other's daily routines, habits, and even have the keys to each other's apartments or houses. This is very much like tight coupling. But other friendships are more casual. These friends might not know much about you. They might only hang out on occasion, and that's more like loose coupling. So in programming, um, we have tight coupling, which is going to be highly dependent on one another. When classes are tightly coupled, changes in one class often affect the other. For example, we have a car example here. Let me see if I can get my laser pointer up. There we go. We have a car example here in which the car actually directly creates its engine. It manages anything that happens with the engine, like it starts the engine, it creates the engine, and any change to how a engine is created would then likely require this to change as well. So any change to the engine itself would also require the car to change. This is an example of tightly coupling. Where we have an engine class, which is separate, yeah, that's fine. And you can have that same class for loose coupling as well. But the class itself for car is the only thing that's creating that, and that's the only thing that's managing that. So it affects how the engine is created and managed. Okay. On the other hand, loose coupling have minimal knowledge of each other. So they interact. We can still say the same engine example, but they don't need to know each other's internal details. If our car class simply accepts an engine that was created somewhere else, as we can see here, where it doesn't create the engine, but it accepts an engine created somewhere else, like an engine manager, or when we have like this loose example here, where the engine's created in a program. It doesn't need to know how engines are made in this case. So it just needs to know how to work with an engine. Here, we'd still start the engine from the car, but we're no longer creating the engine. The car accepts any engine that's already created, and it still has a reference to the engine, so it still has that relationship. But now we have a loose coupling in that the engine is created separately, and the car accepts the engine that we give it. So now we're having a loose example where we just pass in the engine that's created. And let's see. So it's important to understand that coupling isn't simply good or bad. It exists on a spectrum. Some coupling is necessary for classes to work together. In order to have any sort of relationship, they have to have a dependency one way or another. A car needs to know something about its engine to function. The goal isn't to eliminate coupling entirely, but to find the right balance that works for your specific situation. Too much coupling can make the system rigid and hard to change. It's every change to one class requires changes to many other classes. Maintenance becomes difficult and risky, actually. But too little coupling, too loose, can also be problematic, making it harder for classes to communicate effectively. As we continue through this presentation, we're going to see concrete examples of loose and tight coupling and learn strategies for finding the right balance in our code. We'll also see how other principles, like the most restrictive access principle, helps us manage coupling effectively. But before we move on to specific examples, I want you to think about code that you've written before. Can you think of classes that seem to need to change together frequently? Or have you encountered situations where making a small change required updating many parts of your program? These might be signs of tight coupling, which might need to be refactored later or avoided if they're having too many changes that happen frequently, or you're requiring it to update many different parts just by doing one small change. That might be a situation where you're thinking this is probably a good candidate for being loose coupling instead of tight. Okay, so let's look at an example of loose coupling. So let's look at it through something we're familiar with. In class, I've gone over this a few times, the playlist example, but for people that are not in my class, then you'll see this for the first time probably. But a music playlist. Think about how music works on your favorite app on your phone. You have songs and you have playlists that organize the songs. In our example here, we have two classes. We have a playlist class and a song class. I'm only really showing the playlist class, which is fine. But there are two ways that we could actually interact with each other. We could demonstrate some different levels of coupling. First, let's look at loose coupling. This approach has the playlist knowing about songs, knows about the songs here, but it does not create the songs. Just like in real life, where a playlist doesn't create the songs, it just organizes them and it manages them, but it does not actually create the song. So in our code, you can notice as a parameter passed in to add song, we have a song object right here. The playlist doesn't care how the song was created or where it came from. It just is going to add it to the playlist. Now, this gives us several benefits. We can modify songs without touching the playlist. Maybe we want to load songs from files or stream them from the internet. The playlist doesn't need to know or care about these details. Testing becomes easier. We can create simple mock songs or fake songs or simple test songs that are just for testing without needing a full song implementation. So we just test whether adding song works, for instance, to a playlist, or we can just test song on its own. The playlist is now more flexible as well. Maybe we want to add different types of songs like podcast episodes. Our playlist won't need to change based on that. However, loose coupling isn't always perfect. We need to manage song creation somewhere else, and we need to coordinate between song creation code and the playlist code. It's a bit more complex than our second approach, which would be tight coupling. So we have the fact that it's easy to modify independently. We can test with easy sample songs. We'll say sample instead of mock. You probably haven't heard the term mock, but just say example songs. And we can do it's flexible for future changes because we can change song independently, we can change playlist independently, and neither affect the other. But we do have more objects to manage. As you notice, we have to create a playlist and a song instead of the playlist creating the song. And it becomes more complex about object creation because we have to create a song itself and then also create the playlist and then add the song. It's a little bit more complex than it would be otherwise. And we also have to coordinate carefully on this. So let's look at tight coupling next. In tight coupling, in this version, the playlist creates the songs directly right here where it says new song. So we pass in information about a song, but the actual song is created by the playlist. Notice how Add Song now takes in the title and artist parameters and creates the song itself. This approach is simpler at first. Everything happens in one place. And we no longer have to create the song outside the playlist like we did with the other. But the simplicity comes with drawbacks. If we want to change how songs are created, maybe we want to add like a new parameter that's required, like the duration of a song. We have to modify every playlist method that also creates songs to include that new duration. We would have to take in the duration here, just as this very simple example, and we'd have to take in the duration here. So we'd have to modify the playlist if anything about the song creation changes. Testing also becomes harder because we can't separate the testing of the playlist logic from the song creation. Now we actually have to test them together. And the playlist is less flexible. It's locked into one specific way of creating and managing songs. So it's less flexible than we had before. It's harder to test independently. And the changes to a song affect the playlist. But the benefits are that we do have direct control over the life cycle of a song. The songs are created in literally one place, and that's going to be in playlist. Nothing else is going to mess with that. That means that playlist also owns songs. This is an example of a composition relationship. And it's a simpler initial implementation. I say that because if you work with larger projects, it becomes more and more problematic, and we'll go into that. So let's see. Now we can go into another example. So first of all, neither approach is right or wrong. It really depends on your needs. If your system is simple and unlikely to change, then tight coupling might be what fits your needs. That might be fine. But if you're building a large system that needs flexibility and maintainability, loose coupling often pays off in the long run. So consider this. When you create a playlist on your phone, does it create new copies of songs or does it just reference existing songs? And why do you think developers made that choice? Those are important things to think about when you're creating your own projects because you'll have to make similar choices. And I'm sure what most playlists do is just reference existing songs, right? And the reason they need that flexibility, they need that maintainability, And there's no reason for a playlist on its own to create something that already exists on the songs elsewhere. Now let's go into the most restrictive access principle. So this is another key guideline for maintaining class relationships. The principle states that you should always start with the most restrictive access level possible for class members, only making them more accessible when absolutely necessary. Here you can think about a bank vault. The bank vault has multiple security layers. In this case, the outer door is what customers can see. The teller windows are where limited transactions occur. And the inner vault is where only certain employees can access. Each layer of security is as restrictive as it can be while still allowing the bank to function. This is exactly how we want to develop our classes. Let's look at a player class example for a game here. We have a player in the game with various attributes. So how should other parts of the game interact with these attributes? First, we have the health property. Notice how it's declared with public int health get with a private setter. The syntax means that any class can read the health, and that's fine. But only the player class can actually set the health. This is private. This only allows the player class to set it. So private is only within the same class. Next, we have the max health property. Here we have a getter, same as public with this health, but we have a protected setter. So this means that any class can read the maximum health, but only the player class and its children can modify it. So this is useful when you have derived classes like, say, we have a boss player or a hero player, and we need to adjust their maximum health appropriately based on their special abilities or level ups. For name, it's the most public possible. When a property truly needs to be readable and writable by any class, we can use the simple public string name get set, which changes both getter and setter to be the outside public here. So this inherits from the outside, if you notice. This is public get, this is public get, and if we didn't if we didn't set private here, this would be public set. Instead, we have to override the public with like another member, which is private, protected, and here we keep it public. So here we finally we have like we're going to use name for different access. Anywhere can access the name, and we might need to access that in like high scores, and we need to access for that for quests. There might be different classes that need to access that. And if it's only Git, we'll actually get there. I'll go over that in a bit. I'm not exactly sure, but it's in this presentation. But if it's only Git, then it is read only. That means that you have no setter, and that means that the only time it can be created is when you instantiate an object of that class. So it's completely read only. That's what happens when you have no setter. It's different from private set. Private set you can still change after you create the object. If we have something that changes health, like this does, we can change this after the player has been created. But if we didn't have a setter there, then this wouldn't work because it cannot be changed even by its own class after it's been instantiated, after you create a player. So that's the difference between having a private set and having no setter whatsoever. It becomes read-only by any class. And it's okay to do that. It's because you can still create or set the health, even set the name whenever you start, when you do the first initialization, when you make that first player. So if we didn't have any name changes available, most games you can change the name, so I left a setter here. But if you didn't have that possibility, you can just remove the set and create the name once and set it, and that'd be it. You might use that more likely with a unique identifier for players if you have an online game. Then that would be a more likely use of a read-only property. And we try to set them as often as we can to read-only, and I'll go into that further on. But finally, we have take damage. This is a method that has a controlled way to modify health. Even though health has a private setter, we can still modify it with this class internally through this method, which ensures that the value never goes below 0. This is what this does. It takes the maximum of these two. So if health minus amount is negative, then it's going to say that returns 0. So it just assumes or ensures that health never goes below 0. That's what that command does. Okay, so let's actually explore the hierarchy of access modifiers in C#. I'm only going to go through a few. I went through more last week, so I'm only going to go through the ones that are used the most. And how they help us implement the most restrictive access principle. Think of these modifiers as concentric circles of access from the most restrictive inner circle to the most open outer circle. So starting from the most restrictive. So private is our innermost circle here. Only this class can access it. Protected is our next circle where the class and children can access it. And internal is our next circle where anything in the same assembly can access it. And finally, we have the very outermost circle of public where any code in any assembly can access it. Let's give a bit of an example here. So with private, we have our most innermost circle. When you mark a member private, you're saying this is an implementation detail that only this class needs to know about. In this example, we have date time, a private date time save last save time, because only the game class needs to know when the last saved occurred. No other class needs to know that information. Protected, on the other hand, allows access to child classes. It's particularly useful in inheritance. And so, for instance, we'll have I'm not sure, do we use a protected? We could use a protected with this if we want, as an example. But we could have, say, I think score. Yeah, we could have a protected setter for score, for instance. In that case, we have any code can read score, but only the ones that are from game and its children can actually set score. So since we have a multiplayer game here, we can modify score because multiplayer game inherits from game. So multiplayer game can modify score here because it has access through a protected setter. Internal extends the access into everything in the same assembly. Server IP over here, that one has an internal setter. So this keeps our code only within the game's assembly that should be able to modify the server settings, we're saying. So we're saying that only within this assembly can the actual server IP be set. This is useful for keeping certain operations contained within your main code base while preventing external code from making a change to the server IP. Now, public is the most outermost circle, which gives access to everywhere. Player name is completely public because it's part of the game's public API, meaning that we're giving the third-party developers access to the player name. Any code that can see the game class can read and write this property. So any sort of external assembly or internal assembly can change this. Okay, so let's see how this kind of works in practice here. So the game class can access everything because it's all its own code. So it can access everything here. The multiplayer game class can access score because it inherits from game. Other classes in the same assembly could also modify server IP if they wanted to. And the game launcher is in another assembly, we're going to assume. So this is like for a third-party game launcher. And it can only access fully public members, meaning it can access the player name, it can read the score, but it cannot write to the score because it's a protected set, and it cannot compile because of internal set. It cannot write to server IP since it's in another assembly. The difference between assembly and namespace. Well, namespace is just an organization. It's like a folder. So when you have a namespace, say namespace, I don't know, game here would be a decent namespace, even though the class is also called game. But if you have a namespace, you're organizing things into its own folder. Now, you can export things based on whether they're in a namespace or not, but the main way to export things is through access modifiers. When you have a assembly, an assembly takes all the different internal code that you want to put into it and everything that it references, and it can have its own module. And whenever a module like an assembly is going to be exported, then you can have, say, okay, we have a game module over here. We have the multiplayer stuff that might change. You can think of these as like their own executables, or you can think of them as their own shared libraries, like a DLL or an SO, depending on which operating system you're using. So an assembly itself is just a way of exporting code and putting it together in its own sort of a compiled code. A namespace is there for organization purposes when you're actually writing code. So the assembly is more about when it's compiled, and the namespace is more about when you're writing the code. You can have the same namespace in multiple assemblies. You can have multiple namespaces in one assembly. You can have multiple assemblies in different namespaces. All that's fine. They all work together because they're slightly different. Namespace is how you write code and organize it while you're writing it. An assembly is how you compile code and how you update it whenever you release a new version. So an assembly is what gives you access to these different modifiers, whereas the namespace organizes everything together within one folder, basically. That's the idea, is that while you're writing code, the namespace is important for organization. And when you compile code, an assembly is really important for saying, I want only this part to be updated the next time I do a version. So maybe you have the multiplayer as part of its own assembly, for example. That might be important for you in case you change the way your server code actually works. That way you don't have to say, I'm going to release a new version of my game, and you have to recompile every single part of the game. No, you're going to say to the players, well, we're going to change the way our multiplayer game works. Our servers have changed to maybe we have several different server farms now. Maybe we access it to a third party now. And we're just going to make them update that DLL. That keeps the update to the program smaller. And so that makes it so that you can easily do this in isolation without having to put everything in the same assembly and say you have to update every single part of the game if you do any change. But a namespace doesn't do that for you. A namespace is just about organizing while you're writing. I hope that explains it. Okay, so we're seeing these now in practice. And when you're looking at the modifier, we can see um, we can say, how do we start? And should be starting from the most to the least restrictive. If we can say, can this be private? Then make it private. If not, does it need to be shared with child classes? In that case, you can say maybe consider protected. There are other access modifiers within protected, private protected, protected internal. But generally protected is what's used the most often. I personally prefer other ones than just protected because protected can be accessed in other assemblies. Um, but it's easier for people to remember private, protected, internal, public than anything else because they're very simple names. Now, if it should be available only within the same assembly, make it internal. And if it needs to be completely public, make it public. So this hierarchical approach to access control protects your code from unintended changes. It makes dependencies clear and explicit and helps prevent any bugs you have from that by controlling where the changes occur. So think about this. When you're designing your own classes, what questions do you want to ask yourself to determine the appropriate level of access for each member? I've given you some examples. You might have to think about your own depending on the situation that you have. What do your stakeholders want? Do your stakeholders need access to this class? In that case, you probably will need to make it public. What do I want to make sure that is the least given out to, or least required for updates? If it's not required for many updates, there's no reason to have it in the same assembly as everything else, because that way you don't have to require for every version change you have the people that have your software to recompile everything. If it rarely changes, put it in its own assembly. That way you can say, okay, well, this is never going to change. I'm going to have this in its own assembly so that people don't have to recompile this piece of code every time they have a new version. So what questions would you ask yourself to determine that? Now, that was the most restrictive access principle. There's also the single responsibility principle. And let's see if I can get there. All right, all right. This states that a class should have one and only one reason to change, one responsibility. And by responsibility, it always means reason to change. And by that, I mean if you have something that has a print and a display and a generate report, well, those go to three different members of your organization. So having one class have to deal with several different changes, meaning maybe your financial advisor or whoever works in your CFO, whoever works in your organization, your chief financial operator, they might want you to change part of that class. That's one reason to change. But what about your chief technology officer, your CEO? Who all wants that to change? It should only have one reason to change. And that will only mean that whenever one person comes to you, you don't have to modify it based on other people, or you don't have to go and say, okay, my CFO wants it to change for this reason. Now, my other managers want to change it for this reason or want to keep it the same. Now you have an argument that you have to figure out, well, my other managers are using it in this way, and now I have to actually change it based on what the CFO says, but your requirements may vary based on what each person that is in the company says. So you have to make sure that each thing has one single task and purpose. And let's look at something, could I explain, wait, that wasn't me. Yeah, so let's try to look at this through maintaining generating maintainable code. So we're going to say that we have a bad example, and we're going to do this through a social media post. Um, Now we have some good reasons for changing. I'm going to go back into them, but first let's look at an example. So in our bad example here, this a social media post. Let's say something like Instagram or X or Twitter, whatever you want to say. Um, that right now has the information about posts, but it also has handling its own likes, meaning it's basically being its own like system. It's controlling how the post is displayed. It controls basically everything. So think about why this would cause problems. What if we want to change how likes work? Maybe like adding reactions like hearts or laughs or something like that. Or what if we want to change how a post is displayed differently on mobile versus desktop? This is all about changing this one class based on different requirements changing. And what if we want to change what information is stored about a post, not just the content and author and post time? What if we have more information? We have to make a change to this class based on any little part of our system that changes. So each of these would require changing that same post class, even though they're commonly different concerns. So let's see how we actually fix that. So here we have, give a sec. We have every one has a different focus idea. So we've now split this into three focus classes. There's post that handles post data only, just the information about the post. We have a like manager, which handles information about how likes work. It adds a like, adds it to a list of likes based on the username. It gets the number of likes. But that's about all for now for this simple little example. And we have a class for how a post is displayed, which does use a like manager to show how it's displayed, and also uses the author and content. So it uses the other classes, but it does not require any changes based on them. It takes in a like manager and it takes in the post, but does not change based on this. So each separation makes our code better because each class is simpler and does one thing and it does it well. We can change how likes work without touching post content. We can change how posts look without affecting likes or content. And if something breaks, we know where to look. And that's a very important thing. It's like Instagram. They can update how posts look like without changing how the likes work or change their like system without affecting how post content looks. So this is a very important way of breaking up. Now, notice our previous had everything in post. Every single thing about post at all were in there. So any change at all would require us to debug this class and find out which method made an error, and then also have its own like system. We add functionality, and as we add functionality, this is going to get bigger and bigger and bigger and have more and more responsibilities. This keeps things testable, keeps things simple, makes sure that we know what's going to be edited and where. Uh, yeah, let me see if I can. I wanted to do. Actually, I don't think I'm necessary to be shown at this point, so let me see if I can fix that and just display. Oh, no, I need to actually display that. Okay, so let's not actually cover up. I don't think I'm necessary to be seen here, so I'm. You already know I'm here, so that's the important thing. But yes, we have a post that has a single responsibility, a like manager. I think you saw everything else. This probably covered up to about there, I'm guessing. And a just post display. And in the previous one, if I can get back to it, we had just post take care of everything. So if we look at the single responsibility principle, let me see if I can get there. I want you to think about maybe your favorite social media app. When they make changes, do they usually change one of these aspects at a time, like updating the look or changing how likes works? And also, look at your own projects. How many different reasons do some of your classes have to change? And could these responsibilities be separate? By making these things into their own single responsibility, we ask a class to have a single reason to change. We focus on a single specific task or purpose, which makes it easier to understand and maintain, and also makes it loosely coupled, less coupling, and has more flexibility. Next, we'll look into some technical debt. Technical debt is a term that helps us understand the future costs of taking shortcuts today in our code. Just like financial debt, it's sometimes necessary, but it needs to be managed carefully. Think about maybe your bedroom. If you're in a hurry, you might just throw your clothes in a chair instead of putting them away properly. That's quick and easy now, but what happens when you need to find a specific shirt? You'll spend extra time searching through that pile. This mess is like technical debt. You save time earlier, but now you're paying interest in the form of wasting time. In programming, particularly with class relationships, technical debt shows up often in several ways. The first way is circular dependencies. This is when two classes need to know about each other. In our example here, the player needs to know about the weapon, and the weapon needs to know about the player. This creates a tangled mess that's kind of hard to change, like two pieces of string tied together in knots. This is sometimes necessary. We've seen with bidirectional associations, where a doctor and patient need to know each other. But it also can be very difficult to maintain, and it does create this circular dependency where if one thing changes in one, we have to change it in the other. It also occurs when we have tight coupling. When classes are too dependent on each other's details, it's like building a house of cards. Touch one piece, and everything might need to change. Finally, it can happen with classes with multiple responsibilities. When a class tries to do too many things, which violates the single responsibility principle, it becomes like that messy bedroom. Hard to find what you need and hard to clean up. In our player weapon example, here in the det version, if we want to change how weapons work, we might need to change both classes. If we want to add a new feature like temporary weapon buffs, then both classes might need updates. Testing is going to become harder because we can't test one without the other. In the improved version here, player just knows it has a weapon, but weapon doesn't know about the player at all. It doesn't need to know about its owner. Each class is simpler and can be easily changed independently. So now it just gets a weapon passed in, and it doesn't create its own, and it doesn't have it assigned to player. And there's, yeah, which calls it. This is a very circular reference where it calls assigned to player, which is in weapon, but this calls equip weapon, which is in player, and it becomes a very, very complex tangled web, as I mentioned. This here, we don't need weapon to know about its owner. The only thing we need to know is that the player equips a certain weapon. They still have a reference, of course, because this is still about a relationship between the two, but it's a much looser reference. But technical debt isn't always bad. Sometimes you need to move quickly. But like financial debt, you should be aware when you're taking it on, have a plan to pay it back later, and understand the interest rate. How much harder will future changes be? Think about maybe a game you're playing. If a character can use different weapons, does the weapon really need to know who's holding it? Or can it just know about its own properties, damage, range, etc.? So when you're making your own classes, think about how tightly coupled they need to be. Can we make this easier? Do we need this circular reference? And make sure that we have a plan to pay it back later by using perhaps things like refactoring, which we'll go to in a second. So how do we manage this? One common way of managing technical debt is refactoring. Refactoring is like cleaning or organizing your room. You're not adding anything new. You're just making what's there better organized and easier to work with. We'll see how refactoring helps manage technical debt through a game example. We're going to look at how regular maintenance prevents debt accumulation, and we want to plan for future changes, and we want to break complex dependencies, which I'll go into. But let's look first in the example. Here, the problem here is that game character is doing everything. It's hard to find specific things like inventory logic here. There's something about an inventory here and something a bit about it here. So it's going to be harder for us to find when it's just put as part of a game character. We might have to look, and there's going to be much more functions than just updated, many more methods. Changes in one area might affect others, and we can't reuse parts independently, like using the level system that we have here for say, NPCs. And testing is going to become difficult because every single thing is interconnected. So we have the game character managing health, mana, we have it managing inventory, we have it tracking experience and levels, and it's doing every single thing. So how do we actually fix that? Well, our refactored version separates these concerns. The stats are going to be handled here by the health, handles the health and mana. But each class is going to have its own benefit and purpose. So the stats handles the health and mana. The inventory handles items. The level system handles experience and leveling. And so this is like having separate drawers for different types of clothes. Everything is handling its own thing. If we have anything that breaks with the level system, we update the level system. We have anything that breaks with the inventory, we mess with the inventory. We have anything with stats that we want to add or update, then we can easily do that. So everything is going to be refactored with its own responsibilities. Let's go past that. So here we have the benefits are pretty clear. Each class has its own focus purpose. changes are contained to relevant classes, we can reuse components like we can use the same stats class for monsters. Testing is easier because we can test each part independently. So to manage the technical debt, let me see if we can get there. Right here, I think, right there. One more. I have so many of these. Managing technical debt. Um, we want to regularly look for places to refactor. Break up large complex classes where we can. Remove unnecessary dependencies like the circular dependencies where we don't need them. And keep responsibilities clear and separate. Think of it like maintaining your room. Having regular small cleanups, refactoring, is easier than huge reorganizations. Having a place for everything, separate classes, makes it easier to stay organized. When you need something, like making a change, you know exactly where to look. So consider a game character. What other responsibilities might need to be separated? And what about equipment management, skills, or quest tracking? All those could be different individual classes that have their own responsibilities. We're going to try to put everything together now and see how these principles can work in harmony. I'm going to go through this and then we'll take a break after we're done with the best practices, I think, and I'll finish up with key points after that, and then we'll do a coding example. So let's pull everything together first and see how these principles work in harmony. Our example here shows a simple game system that demonstrates all the best practices we have discussed. Okay, first let's look at how coupling is managed. So we have game, which doesn't create its own components. They're passed into game. Each class has its own boundaries. World has its own boundaries about valid positions. Position is just an X and Y. The player has its own information about the name, its current level and position, and its movability and level up, very separate from each other. And then we have the classes interacting through well-defined interfaces. We have everything that is defined here is interacting through being passed in or having its own information accessible to only it. We have a move that's accessible by player only. We have level up that's only done by player. So everything is well-defined. The most restrictive access principle is also evident. Where possible, let's see, we have read-only access modifiers. So right here we have name that is actually read-only in this case. We don't have the ability to change the name. We do have private setters for for level and position. We also have for valid world positions and only a getter with no setter. In that case, it makes a very good sense to have a database of valid positions in the world to move. And that would be something that you would have for a map. There's no reason to set it after the game is started. Once you load that in, it should be fine. And we have read only for position, get for X and Y. When we set a position, there's no reason to change it. We just create a new position. It's just a simple support class. Single responsibility principle is also maintained. The player, if I can get back to it, the player manages the player state. That's all it access. That's the only thing it manages. It's its own player state. The world handles its world rules, and that's about it. The game coordinates, they game coordinates, but it doesn't actually implement any details. So it actually has access to these, but doesn't implement anything. It doesn't create a new player. It doesn't create a new world. Everything is loose coupled. They're passed in, not created here. And position handles the coordinate logic for the current spot in the map. Here we've avoided technical debt by keeping the classes focused, by making the dependencies explicit, by using clear intention revealing names, and by making future changes easier. You can think of it like building with Lego blocks. Each piece has a specific purpose. Pieces connect in clear, limited ways. You can change one section without rebuilding everything, and the structure is stable but flexible. So, when you're looking at your own projects, how could you apply these principles that make your code clearer and more maintainable? We really want to keep our relationships clean and clear. We balance the coupling needs, use the most restrictive access where we can. We focus the responsibilities to one responsibility per class, and we manage technical debt early and often, meaning we're going to refactor, changing the structure of the code without changing its behavior. And I will give us a break there, I think, since, it's just going to finish up with key points, but I'll give us a 15-minute break there. We'll come up to that, and then we will go into a coding example. Okay, so I'm going to set up a break. I think this will be it. Let's see, loading everything. Make sure, check my mind. Yep, good. Okay, I want to finish up with the key points. Just to recap what we've just covered. You've had a little bit of a break, so maybe a little bit of time to think about it, and then we'll go into a coding example that illustrates these concepts. So first of all, we discussed coupling. And these are all about how to manage class relationships effectively. All these key points are. This whole presentation is about how to manage these effectively. So coupling is about how much classes depend on each other. Like friends who are too dependent on each other, tight coupling can make changing difficult. We want to find the right balance, enough connection for classes to work together, but not so much that they can't function independently. And so here we go. Oh, wait, stop. That was not what I meant to do. I clicked the wrong thing there. Yeah, we should be back. Anyway, that was, I hit the down button and I must have hit it on OBS instead of the presentation. Anyway, on the most restrictive access principle, that's our guardrail. In C#, we do this primarily through properties with controlled access to their setters. Start with the most restrictive access possible and only open it up when there's a clear need. So you can think of this as like sharing information on a need-to-know basis. For the single responsibility principle, this tells us that each class should have only one clear purpose or reason to change. When a class tries to do too many things, it becomes like a Swiss Army knife, capable of doing many things, but not doing any of them particularly well. By keeping classes focused, we make our code easier to understand, test, and maintain. We discussed finally technical debt, which accumulates when we take shortcuts in our design. Like cleaning your room, regular small cleanups, refactoring, is better than letting the mess build up. When we see complex dependencies or classes doing too much, that's a sign we need to clean up our code. Now, these principles work together to create maintainable, flexible systems. As you build your own projects, regularly ask yourself, are my classes too dependent on one another? Am I exposing only what's necessary? Does each class have a clear, single purpose? And am I making changes today that will make future work easier or harder? Okay, so that's the presentation for today, and I want to go over and do some coding as well, because I like to always have some coding that we do. And for this, I'm going to use VS Code as usual. You can use whatever IDE you want. And I'm just going to start up a project. I'm going to open a folder and create a new folder. First thing I usually do when I start a VS Code project. And let's see if I can actually get to the C# projects at this point. I'm just going to create something that is for an RPG combat system, since we've been looking a lot about game code today. So let me go ahead and do that in a sec. Set up here. There we go. Now I can actually type. Okay, so I'm going to create a new folder. First of all, I'm going to call it RPG Combat. And I'm going to select this folder. Okay, as usual, whenever I start a new Visual Studio Code project, I go into the terminal and start a new console project for this course. That's all we're really going to be creating. I might do a lecture on how to create assemblies, which would be using slightly different code than just doing a new console project. But for this, we're just going to do .NET new console. And for whatever IDE you have, just create a new console application. Okay, so we have a new console application, and I'm going to get the code zoomed in, and we don't need most of this, and we can scroll down here just so it can be easier seen. We've already got program.cs. I'm going to put our requirements for the code in here. So first of all, let's do this. I'd rather have a little space there. There we go. And I will put the requirements. So requirements I've made for today. We're going to create a simple RPG combat system. We're going to have characters. Ah, type. Have basic stats, health, attack power. Different character types. For this, we'll just do warrior and mage. We're going to have basic combat where characters can attack each other. Basic status display, output to the terminal, in other words. And I want the system should be able to, or should demonstrate coupling, access control, and SRP. And I think that's about all the things I want to do there. Okay. Now, next, we normally will create a UML class diagram, and since my mouse has been acting up, I might just skip that step, but I'm going to make sure that we are able to convert to a class structure. So we'll still go through the step of converting to a class structure, which would be one-to-one with a UML diagram. But for time considerations, and because it's a slightly larger class, I'm going to skip making the UML, but I will make it and release it though. So first of all, I'm going to go out of this class and create a character class because everything's going to inherit from character. So I'm going to have a character.cs. Okay. So this is going to be, let's see, let's say namespace, and we need RPG combat. And then we're going to have public class character. And for this, no, not S, there we go. I have to, 1 second, I have to re-enable this. I forget, whenever I take screenshots of things, I disable my C sharp. C sharp. I've got that disabled, as you can see. Yeah. And I should be able to, don't show again. I know. That should be all right. Should be able to, and reset that. Try to open that back up. Let's see if that does it. Yeah. I'm pretty sure that I have a version that wanted to update just a bit ago. But I think I should be able to reload it. I'm just going to reload VS Code. Because I take screenshots, And let's go ahead and make sure that we have everything. That's interesting. Okay. I probably enabled the wrong thing first. Let's disable you for a sec. Yeah, okay, let's restart the extensions and see if we can do that. All right, we should be able to, at that point, have a actual thing. I'm just going to do, there shouldn't, we don't have a main function, so we shouldn't have any issues. But let me go ahead and restart VS Code one last time. You won't have this problem. I've just disabled C sharp. And hopefully we'll get it. If not, then it's fine. I can do it without the typing and everything. I was hoping we'd have a little bit of access. The main thing I was trying for was summary. But okay, this will be fine. Let me just see if I can actually do a .NET. Let me create a class real fast, and I'll do namespace, RPG combat. I'm going to make sure I can create a main method in my program.cs. Public class program, and then public static void main, no arguments, and just, I don't know, console. Let's see if I can get mine to actually compile. No, not there. .NET run. Let's see what we got here. I might not be able to if I have to fix some things. Worked. Okay. It seems to be working. That's all I wanted to make sure of. So for yours, you'll have a little bit more IntelliSense than I'll have, which is fine. I can work without it. I'll fix mine later. But this is going to be, and do that. Should be able to do that. There we go. That should work. Okay. Base class for all character types. Yours will type this stuff automatically, by the way. Mine is not going to, unfortunately. Okay. So we're going to have a public property about the name, similar to what we had before. Name can't be changed after creation, though. So we will have a public string name, and I get it. And then we'll have a protected property with a private setter, and that means that derived classes can read, but only this class can modify. And that's going to be our health. Protected, and we'll do int health. And here, now this makes it even more protected than we saw with the public getter. We can only actually access health through the this class and children classes in private set. But it's very similar to what we saw. Protected property, attack power, which derived classes and read, but not modify. So this is going to be our protected int attack power. Get, and then it's going to be read only, and I can type a little better than that. And then we're going to have, let's say, a constructor to initialize a character. Public character. I'm going to have a string name. Going to have an int health, and going to have an int attack power. And here I'm just going to say name equal name, and then we're going to have health equal health, and attack power equal attack power. Now you could use a constructor that's a primary constructor and put that all here. If you want to, if you like C#11 and above, then you can do it that way. This is the standard way of doing it. And I can probably hide some of this terminal stuff again. By using any of the other C# versions, this is the way that's suggested. And it's not like private or the constructors over here, the primitive constructors, are not going to be replacing these. So you can do it that way, but I'm going to use this standard way of doing it. All right, so we have a character. That's all we need to do, I think, for that, except we're also going to have some way of setting the attack power with the classes. So we need some sort of virtual method, right? So let's say a virtual method can be overridden by derived classes. The base version just returns basic attack power. And this is going to be a single line method, public virtual, and we're going to have an integer for attack. We could do a float. I'm going to do an integer. And then that's just going to be a single line that returns attack power as its base. This is a simple way of doing a single line method here. Instead of saying, you could also do this. Attack, and then that's the exact same thing. But it's so much simpler just to do this lambda expression. This is called an expression body member. Because I forget which version actually, 9? I think it was somewhere around there. then so that's just a single line and it just returns attack power. And then I'm going to have a way of, let's say, doing damage. So we'll have a public method to handle taking damage. We're going to use math.max as you saw before to ensure the health doesn't go below 0. All right, 0. Just do that. So we'll have a public void take damage, int damage. And again, you could use float if you want. I'm just going to use integer mathematics. Math.max, and then the maximum of 0 and health minus damage. Okay. Then we'll have a public property to check if the character is still alive, since we're doing a combat situation. Public bull is alive, and then that's another single line, so we're just going to do health greater than 0. If the health is greater than 0, then it's going to return true. If the health is less than equals 0, then it's going to return false. This can't be less than 0, of course, because we've already said take damage prevents that, but it can be equal to 0. And then we're going to have, you saw in the last presentation that I did that we have this get info that we were overriding with the coffee house. But C# also has a built-in toString method that does the same thing. And we can override toString instead of having our own get info, and we can just use the built-in property then. So we're going to override toString, which again was like our get info. It's pretty much like that. To provide character status. Public override string toString. This is a built-in method for pretty much every single class for C#, where you can override the toString, whatever happens when you do, and that's whenever you do something like you have a character, say a lowercase character, not toString. It overrides that method. And we're just going to provide some info. We're going to use string interpolation, and I'm going to say name and health. That should get our status display done that we wanted to do. Okay, so for this, we're going to have the name, the health, the attack power. We're going to take in the name, health, and attack power. Again, you could have used a primary constructor instead of what I did. You could have used a float instead of an int here, but I'm basically just going to return the basic attack power, and derived classes can override this and have their own attack, which they will. I'm going to demonstrate that. We're going to have a public method to handle taking damage. We're using math.max to make sure that it doesn't go below 0, so it's the maximum of 0 or health minus damage. Therefore, if health minus damage is less than 0, it makes it return 0. We have an is alive because we're doing a combat system only. We're just going to check to see if a character is alive or not. We're not going to override that. We're just going to say, because it's simple Boolean, it's the health greater than 0. If it is, then it's still alive, otherwise not. That is our character class. Now we're going to have, like I mentioned in the program, we're going to have a warrior and a mage, and each of those are going to derive from character. So let's go ahead and create our warrior class. Warrior.cs and namespace, and let's go ahead and call it our peak combat. And public class warrior, and let's do character. All right, so I'm going to use for the combat just like a random number generator for some things, mainly so I can get it to work without much effort. You could have an actual specific warrior that you were thinking of in your game, but I'm just going to use a random number generator. So a random number generator, and for warrior, I'm going to have it be able to do critical hits. I'm not going to have that for mage, just to show a difference between a warrior and mage for critical hit calculation. All right, so private random random equals new. All right. Then we'll have the constructor. And this is going to call the base constructor, which is the character class, with some warrior specific stats. All right. So we're going to have public warrior, and we're going to take in string name, and we're going to have, oh, let's say an int for the health, and int for the attack power. And then that is going to call the base constructor. I can do a code. Base name, then we'll do health, and we'll do attack power. And I don't think I really need to do anything. I'm going to pass it on to the base constructor whenever we create a warrior. That's it. Now we're going to override the attack. If you remember, I created a character an attack that can be virtual, so it means it can be overridden to have its own special abilities. And so for warrior, I want critical hits. So let's go ahead and look at that. So override the attack method to implement critical hits. Public override int again, which again, you could do different things. I'm going to give a 20% chance for a critical hit, which means that numbers 1 through 20 out of 100 are going to be for critical hit. So I'm going to use an if statement with if the condition is true, then does the thing in the block of code. So the condition I'm going to look at is using the random. I want to find the next random number that is between 1 and 100. To be between 1 and 100, you have to do 1 past the number because it doesn't include the maximum. And then I'm going to say that's less than or equal to 20. There we go. And then if that is true, then return attack power times 2. Okay, so that is going to be critical hit does double damage. Otherwise, let's do else. This is otherwise. If that's false, meaning it's greater than 20, we're going to return the regular attack power. And normal hit does regular damage. Okay, that's all I really need for the warrior class. I'll go ahead and give a little bit of a summary. For the class, just to say what it's about. And this is the warrior class. Specializes character with critical hits. And you can use your own comments, whatever you want to use. I'm just putting some basic information down. That should take care of warrior. And again, we're only overriding the attack. We didn't put anything else that can be overridden. ToString is overridden in character. We could override it again from in warrior if we wanted some different information, whether something was a critical hit, for instance. We could say, oh, you also had a critical hit. But I'm just going to make it simple. And so we just have our warrior just has a created random attack number and has a 20% chance of a critical hit. If it gets it, then it has attack power times 2. We're going to do something very similar for mage, but it's not going to be able to do critical hits. Instead, we will have it do a bit of extra damage or maybe even not as much damage. Just going to give it a random number. So let's create a namespace for RPG. So this all exists within the same namespace, within the same folder. We're going to do public class mage, which also inherits from character. And do that. And then we will do, all right, summary. And this is going to be a mage class. Crystallizes the character with variable attack power. So instead of having a critical hit, it'll do variable attack power. All right, so that should do that. Now, I'm going to again have a random number generator for the attack variation. Since we're using it so differently, I'm not inheriting from character or putting in character. And some classes, if we create different skill classes or different class types, then we might not have, like an archer might not have this random number generator that we're doing. So we're just going to put it within the class that uses it. So new. All right. And then we'll have the constructor, which is going to call the base constructor, which is the character one, with mage specific stats. Okay, so now we'll do public mage string name int health int attack power, and that's just going to call the base constructor with the name health attack power. And I don't really need to put anything in there either, but I am going to override the attack method to implement variable attack power. Okay, so for this, I'll do another public override. I will copy the code that it's learning, just like I did with the last yes. And let's see, what was I doing? Yes, override the time and public override, and this needs to be int attack. I will also upload the UML that I'm not showing today, but that's because we're a little bit low on time, so I want to make sure that I get everything done. Attack power varies between by -5 to +5 points off its base attack, basically. So here I'm just going to return attack power, so plus, and then I'm going to do random dot next, and I'm just going to say -5 to, again, we have to do one more than the maximum of +5. We have to do +6 since it does not include the maximum number. The 5 is not included. This would just go to 4. In other words, that goes to 5. So we're going to have the base attack power plus a bit. It's either going to be -5 to +5, just to get some variation. It can't do critical hits. Like pretty much most mages can't do a lot of critical hits anyway, which is a little bit sad, but it's magic. But yeah, that should work. I think that's all I need for mage. Yeah. Okay. So now we actually have to have the combat class. So we'll have that combat.cs, put namespace, and we'll do combat, or not combat, RPG combat. Base calls the base constructor. So whenever you see this base here, that means whenever we create a mage object, whenever we say new mage, it calls the base constructor. The base is character. So it's going to look at character and call this. It passes the name, the health, the attack power, and sets it here. That's what that does. It creates the mage, which calls this constructor right here. So in mage, it'll say, okay, you pass me a name, a health, and attack power. I'm going to pass that on to my parent, the base. And the parent of the class is character. And that is right here. So I'm just going to pass the information over. That's all it does. So base, that's why I say it's important to remember that these are called base classes and derived classes, not just child and parent, because they do use base as a keyword. And so it is important to remember that the base means parent. Because they don't say parent here, right? They say derived classes when you're looking at access modifiers, and they say base whenever you want to call the base constructor. All right, so I was on combat. All right, so for the combat class, let's say summary, and close, and I'm just going to say that this is the combat class, which handles the battle mechanics. And we'll do public class combat. Okay, so we're going to have some private fields. to store the characters involved. Basically, we're going to have an attacker and a defender. So it's going to be one-on-one combat. Private character, and we're going to do attacker. Private character. Thought that was a capital. Defender. And we are going to have a constructor that requires both characters. Public combat. And we'll get character, attacker, and a character, or yeah, defender. And since we use the exact same name as this, we can't just say attacker equal attacker, which is why some people and use underscores for private fields. Instead of doing it like this, you can use an underscore, which is it's not a required convention, but it is a convention to do. I tend to not because it's ugly and it's not a required convention. It's not like part of a standard because C# doesn't have like a standard like some things do. But in order to distinguish between this attacker, which has the same exact name as this attacker, then we have to say this. This class's attacker is equal to that. That's all it does. It's referencing this class. This class's defender is equal to the defender being passed from this method. Alternatively, you could use underscores or call these something else. But this keyword is still used every once in a while, just for this purpose, really, just to distinguish between the one that exists in this class and the one that's being passed into the method. And that's all I need to do there. Method to execute one attack is going to be public void execute attack. Okay, so we need to get the damage done by the attacker. I'll say damage amount from attacker. And we'll say int damage needs equal to attacker dot attack. And then we apply the damage to defender. Okay, so we're going to do defender dot take damage. Okay, then we're going to display the result. Console.WriteLine, and we're going to use string interpolation. Attacker.name attacks defender.name for damage. There we go. And I think that should be fine. And we're also going to do, since we did, if you remember, we did in the combat class, we did an override to show the current name and health of the character status. We're going to use this toString now that we overrode it. So we're just going to use it in this combat to print afterwards by doing this, console.WriteLine. And I'm just going to do defender.toString. And that will again print the name and the health of the defender. All right, and go back to combat. And I think that's all I need for the combat situation. We have an attacker, we have the defender, we have an attack that executes from the attacker to the defender. That's pretty much a simple basic stat. And then we need to put it all together in our program class. I've already created the RPG combat namespace for this. This is going to be our main program class. It's a very simple comment, but you can create better ones. This is mainly to illustrate creating some comments. Where I tend to do this for classes and methods, other than maybe main. I might do it for main, but you could do like summary here. And you can put information there, but since it's our main, I never usually do it for main since we know what it's going to do. Okay, but we do need to create our two characters. So here we need to say, what am I going to have for the damage? Let's see, for program, I want to create, yeah, so we're going to do you can do var, by the way. You don't have to do warrior. You don't have to do mage. You can have it figure it out if you want. And there, I'll show you the two ways of doing that. Let's do it with warrior first. Warrior, warrior equals new. And then I'm going to call it Conan, why not? Health. By the way, you can do something that uses name properties. You don't just have to pass it in a number if you don't remember the property. Um, like I have to pass two numbers in right now. I have to pass the health and the attack power, right? So those are two things I know I have to pass in, but I might not remember which order that I put that in. I don't always want to go to warrior and say, which order did I put this health? Which order did I put this attack power? So you can actually reference things by name if you don't remember what they are. And I'll go back to the program. So I'm going to reference them by name. And I can just say health and put a colon, and that references the health property that I access by name, and say he has 120, and then attack power. And all this does is make sure that the health gets past 120, the attack power gets past whatever I'm going to pass it, which is 15. And that's something you can do. You can leave those off if you remember which one was health, which one was attack power. You can do this. This just makes it so that you can, first of all, remember or tell it specifically what you want. You can also reorder. Like, even though I put health first, I can actually do this, and that's perfectly fine because I'm telling it which order I'm putting in. Here's the attack power, here's the health. So you don't necessarily have to call it in the order so long as you give it the name of the variable. You do have to remember the name of the variable, though. Now, we could have done this instead, and I'll show you the difference. And since mine's not giving me, it's not going to give me errors, so I'm just going to do this. If we do it this way, we do have to say new warrior because it doesn't know what type we're going to give it right there. And then we would do Conan and health 120 and attack power 15. So you could use var and do a new warrior, or you can use warrior explicitly and just say new without using warrior here because it knows now that that is a type warrior. Both are acceptable. In C# var is used quite often, so it doesn't really matter. Which one you prefer is your cup of tea. It doesn't matter to me. I like to do it this way myself, but perfectly fine either way. They're the same thing. And then mage, and we'll say mage is equal to new. How about Gandalf with a health? And I'll give him 80 health and higher attack power. Okay, so that will create the two characters. Next, I need to actually do something with the code. Let's see, what do I want to do with it? Putting these two in there, then we want to execute attacks. I want to display some initial information, I think. So let's display some initial battle stats. Display initial battle state. Console.writeLine, battle begins. Okay, and then console.writeLine, initial status. And then we will go ahead and do a console.writeLine and say the warrior. Remember that we overwrote toString, and you don't actually have to call toString. It actually is called by default if you do it in the WriteLine like that. So we did override that to give information about it. So we don't actually have to do anything but other than that, but it's the same as doing this. And again, that was just like our old getInfo method that we created. You recall that one? So this, we're just going to do this, which calls toString, which is available to any C# class. So you can do that anytime you want to override toString with getting information. Okay, and then we'll put a blank line between everything. Warrior, right line. There we go. Now we have a blank line. Now we're going to create a loop, which again just repeats code inside of a block. And a block is just this. The block is just the two braces. We're going to basically check to see whether both characters are alive and continue doing the battle until one of them is dead. So while we'll use that, there are several different types of loops. There's do while, which I don't usually cover, but while something is true, do the thing in the block. There's for, then that one does for some number is equal to like 0. Then you go to a certain number, and that way you do a certain specified number of iterations, and you usually increment past that. There's for each, that usually is for collections, for lists and dictionaries. The while is more often used for things like this, where we're having a single block that continually repeats things until a condition is not met anymore, such as a console-based UI. Like if we have some sort of interface that we're showing the user and we say, press this button to exit, we usually repeat that loop. So for this, I'm just going to check while warrior.isAlive and mage.isAlive, not initial, it's alive. Okay. The warrior takes their attack. Why not? This is just an example. And here I will say, and I'll just use the bar as an example. Warrior attack equals new, and we had to create a combat. Warrior being the attacker, mage being defender. Now you could set up who's the actual first character and have the mage do first. You could have a random number generator and say whichever random one, flip a coin and say this one starts your turn. There's a lot of different ways you could do this. I'm just having the warrior attack first. No particular reason, just to make things simple. Warrior attack dot execute attack. Then we need to check the status. Okay, so the warriors attack the mage. So let's see, check if mage died. Playing the get info. Originally, we created and I'll show you from the character class. Originally, we created in the coffee house example, we did this. We did like a public virtual string get info, and then we did return, and it was like dollar name dash health health health. This is what we did with the coffee house example. But we don't actually have to create our own little get info because we can override toString, which is built into C#. So whenever we want to display info, we were using this, but we can just override the built-in C# method, which is meant for that purpose. That's the only thing. And you don't have to do it that way. You can do it with the lambda, just like the toString, and it'll look exactly the same. The only difference will be the name of the method. And I have virtual here because you actually do have to create your own method for this. This isn't built in. For toString, the reason we use override instead of virtual is because it's built in C# as a virtual method already. So we're just going to override whatever the toString is by default and say, this is what happens when you do a toString, like the character.toString. We give its name, we give its health. Instead of calling get info, we just call it toString. That's the only difference. For this, we would have to override in the child classes, but we don't even have to do that. Does return work here the same as console.writeLine? I'm not sure what you mean by does the return work here the same as console.writeLine? You mean if we could do in here where we did console.writeLine warrior? No, we would have to do .get info. We would have to do that, but very similar. This, because toString is such an integral part of C#, they've kind of put it there by default and assume that you do a toString. So it's kind of nice that they did that because it's so often done. But this is unnecessary, so I'm going to get rid of it. But it's the same thing. It's just built into C# is all. So we would have had to call .getInfo, but we don't have to call .toString because it assumes that. All right, so there was that. All right, now we have to check if the maze died. And so again, we're just going to use an if statement here. And this is going to check whether or not the mage is alive. If not, mage.is alive, meaning they're dead. If I can type properly. There we go. Then we're going to do a console.writeLine. And I'm going to say, I'm just going to put a blank line first to put a space before it. And then do another console.writeLine and dollar to put a string interpolation, warrior.name wins. Simple enough. And then we'll just break out that loop. So break will break out whatever loop that you're in. The first loop. If you're in a nested loop, it only breaks out of the very most inner loop. We're only in one loop though. So it's going to break out that while, and we'll do something afterwards, but we're going to just do that for now. And then we'll do another console.writeLine for blank line. So we know at this point, because we break out of this if they're dead, we know at this point the mage has to be alive. So let's go ahead and let the mage take their attack. So mage takes their turn. And we're going to do var mage attack equals new combat. And we're going to do mage is now the attacker and the warrior is now the defender. So mage attack dot execute attack. And just like we did with the mage, we'll say check if warrior died. So if not warrior dot is alive, then we can say we can just do console.writeLine, just like we did up there, writeLine, and dollar, and this time we'll do mage.name wins. Okay, and then we don't have to do a break since it's the last thing we're doing, but just to be consistent, I'm doing a break. I want to delete this line, thank you. Okay. Actually, I am doing this for a reason. I want to, if they're both still alive at that point, I'm going to give a chance to have a pause between rounds. And to do that, I'm just going to do, first of all, console.writeLine, another blank line, console.writeLine. And then I'm going to say press enter for next round and do a console.readLine. Okay. So let's see. I think that's pretty decent. I think that should work. So now I don't think we actually do anything afterwards. Yeah, so we're just going to do this until someone's dead. I guess I could have put something to exit out if we wanted to. Like for instance, we could say and do another, if you do a key press or enter a certain string, then you can exit out the combat. But for this, I'm doing something very simple. I'm going to see if this actually runs since I don't have any of my tools handy here where it does any IntelliSense. We'll see. Might cause an error of some sort. I haven't checked it, but no, okay. Okay, so the initial status, Conan starts with 120, Gandalf starts with 80. Conan attacks Gandalf for 15 damage, which gave him 65. Gandalf attacks Conan for 17 damage, which gave 103. Now we got 35 and 88. So Conan probably, this is why I said we might want to override two string inside the warrior class to say when it does like double damage. See how it did the double there? And we can look at that too, because we have a little bit of time to do that 1-2 string. But we continue on to the next round because he did a critical hit, is what I was saying. And then 15, 22, most likely, since there's a chance of doing critical hits, that I would say that we have favored the warrior in this particular battle. There we go. And then Conan attacks Gandalf for that. Gandalf has 0 health. Conan wins. Okay. That's pretty much what we have. We could, again, like I said, we have, let me go scroll down a bit. We have this 2 string that overrides with the name and the health. We could override 2 string in the warrior class since he does double damage. to make sure that whenever we do an attack, that we also say how much damage he does. That's one thing that we could do, but I think since we only have 5 minutes, I think we're going to leave it off. That is something that you could do. So let's look at what we've done. How does the program recognize that you press enter? The console.readline. This reads into the enter key, basically. If you can type anything you want. I can type that, but I have to press enter for the next line because it's looking for the next line. Looking for the next line, so I had to press enter. That's what read line does. You can do read key, which would look for any key. I think it's read key. I have to remember because I don't have my IntelliSense. Then I'm just pressing a button, any key whatsoever, and it does it. And that's different. You shouldn't, press. You can do any key at that point for next round. And then I can just do any key, any key. There we go. And almost always, Cullen's going to win because of the way we've defined the health and the attack. We might want to have given Gandalf maybe like I don't know, like 35 or something like that. We would have a little bit a better chance, maybe even 40, just because we probably would get a little bit better though. Okay, and then we have like, see if we get any chance. Gandalf wins at that point. There we go. So there's a little bit more of a chance, and then that's where you do like some different testing on the attack powers. Yeah, but if you don't do this read key, sure, you can just get rid of all this, and then it'll just continue. There we go. And then we can look at the terminal and see. I probably gave too much attack power for Gandalf now. Oh, come on. There we go. Come on, scroll. I hate my mouse sometimes. There we go. Okay, so here it goes. Battle begins and just keeps going. I just put a pause in between the rounds, and that's what it does. Yeah. Yeah, I probably should have gotten like less because the most damage that Conan can do is what 30, and we have like somewhere between 35 and 45 for this. So that would be something that you'd want to test, and that would be between 25 and 35. Still a good chance of winning. I might want to do that instead, and that might give them a little bit more balance. And that's where you do game balancing and things like that. And so Conan did have a chance to win, and then you could just test and see how often does Conan win. Conan wins. Conan wins. So is that better? Not really. Conan's win every time. So I would say we could, do a little bit better, probably 28, something like that, and see if we can do a little testing and see if Gandalf wins most of the time or if it's pretty even at this point. And of course, it also depends on who attacks first, right? We didn't, but this is more even now, right? A little bit more even. Yeah, I'd say it's closer, right? So that's a little bit you can test on your attack power and stuff like that. But yeah, the read line was just the pause in between rounds. That's all. And I think I'll do. I like mine a little bit better. I'll press enter. There we go. Yep, starts at and it does 15 and 23, 15, 24, 15, 24. It depends on how much time the critical hit works as well, too. So you did 30 that time, 15, 15, 15, and 30. That was a closer battle, actually. But that's nice. Yeah, that's pretty much what we got for today. This is a full implementation. I wanted to take you through the code a little bit before we head completely out. Okay, so we have a character class at the very beginning that, well, let's go for the requirements. We have created a simple RPG combat system. The characters have basic stats, health and attack power. We have different character types, warrior and mage. And we have basic combat where the characters, the characters can attack each other. And we have basic display output. And the system should demonstrate coupling, access control, and SRP. I'll write those in later how those do that because we only have a few minutes here, or maybe even a minute. But they do actually demonstrate this, as we can tell from like the private sets, the read-only properties here, the fact that character only handles character stuff, the fact that combat only handles combat stuff, and mage deals with its own mage ability, and warrior deals with its own mage or warrior attack. So they all do have separation of concerns. They are as protected as we could have made them. We have privates for this. So you can see that it all actually works out to where we built this in a well-defined way. We did some testing just a second ago on showing how we could change up the amounts that we give the initial attack power to. And that itself was a game balancing thing where we could just easily change that without having to change any other class or anything else. All we did was change it, excuse me, a number. And that was it. So we have all this where we have the simple character class, which simple properties, name, health, attack power. And then we have this basic attack power, which means that if we didn't override the attack, if we didn't have this basic override for attack, it would just done the attack power. We put a little bit of variety in the mage, and we put a little bit of critical hit chance for the warrior. And the warrior inherits for character, and so does the mage. We create a random number generator to do a little variety for the mage and for critical hits for the warrior. Simple little combat system. The combat system itself just takes an attacker and defender. So like I said, it doesn't matter who we put as first player or second player who's the attacker or defender. We don't have to change whatsoever. We could just change the way we're calling it. Right now, we have it to where the warrior attacks all the time first, but we could flip a coin. Or, if it's a real-time combat, maybe whoever approaches the other player first, that sort of thing, could attack first. Whoever has the initiative, you might even have a skill or an ability in this that determines whether they're the first player by a luck parameter, for instance. But we just did warrior then mage, and we wouldn't have to change combat whatsoever if we wanted to change that order. We could put the mage first without changing combat. And that allows us to test things and change things in isolation, which is nice. This is very flexible code here. It's actually really well done. So this is, doing my own horn, but it's actually pretty well done. Okay, but I think that demonstrates everything that we've done for today, where we have coupling. There's pretty loose. The combat takes in an attacker and defender, doesn't create them. The character is the main class that has basic properties, and then we inherit from that. And the program puts everything together with a simple loop that executes anything within these braces and just checks to see if this condition is true once it starts back over. Are they both alive? If so, then we'll do another combat round. Okay. For tomorrow, we're going to let you do 4.3. So I might do a small stream on setting up assemblies, but the fact is the setting up assemblies that I will do is going to be very VS Code specific. So I might only do that as a recorded stream instead. But nonetheless, I would like you to focus on 4.3 exercises for the ones that have the book there at home. For the ones that are in the course that are not my students, they're actually viewing my stream live right now. I am going to be starting this class over. Hopefully on Monday, I'm going to try to be doing both a review for my current students and also a brand new course starting over with this. We started with chapter 4 here, in other words, and I'm going to start with chapter 1. And it will probably be based on the second version of my book, which I've been working on as well. I'm starting to feel a lot better. And for the students that are here, they're in my course. I do have an announcement to make I'll make it on It's Learning Official, but I have worked out a deal where I will be staying overnight at a hotel in Cinnabar on Tuesday nights. So I will at least be there in class, in person, on Monday, or not Monday, Wednesdays. I won't be there Thursday. I'll be doing exercises on Thursdays, but this was the best solution that we could come up with for the rest of the term. I'll make the announcement on It's Learning. I'm still working out where I'm going to stay exactly, but that is the deal that I've made for the rest of the term because I've been looking for ways of getting back into the course, because DSB, our train stations have changed when they're doing the train, which is what has prevented me from being actually in class until like 11 to 11:15. But if I stay overnight on Tuesday, I'll be there at 9:15 in the morning, which will give you more access to me, which is good. I will still do the online streams, just not on Wednesdays. I'll be doing those on Mondays, and they'll be review streams mainly. And for the people that are not in my course, there'll be free education on OOP course completely. where I'll go over every single detail, starting from what classes and objects are, going on to the logic behind classes and behind behaviors, and then of course going into relationships between classes, then going on to advanced relationships and going through program execution, error debugging, that sort of thing. So I will be there next Wednesday is the plan, in person. So I won't be doing a stream on Wednesday. If I do it, I might do a small stream tomorrow, but it's probably not going to be, I'll probably pre-record that stream, just for the assembly making, and because it's so focused on VS Code, and I know a lot of people don't, well, a lot of people do use it, but not everyone uses that. So I will show how to do that in VS Code. But otherwise, I want you to be in class working on 4.3 with the instructors that will help you. And for the people that are wondering what 4.3 even is, this is based on a book that I've been writing. So I will eventually give access to people that are on Twitch. Access to the book is, I'll have to mention and give a link at the beginning of each lecture, most likely, because you can't really add things to a Twitch stream like you can on YouTube. You can give it basic descriptions, so that makes it a little bit simpler, but it's not as easy as just adding things on like it is in YouTube. So I'll be adding both. But okay, yeah, for now I will call it good. And again, tomorrow focus on 4.3. If there's a stream, it's not going to be live, it's just going to be pre-recorded. So don't worry about attending for the stream, but worry about attending for class. And again, if you're not in my class, then this is going to be starting free education hopefully on Monday. I'm feeling better, so as long as I'm able to continue writing the book, then I should be okay and we'll be set. If I'm not, then we'll make different choices. But I do have the rest of the content filled out. Anyway, thank you so much for being here today. I think that pretty well covers it, so I will let you go. And so hopefully you get 4.3 done for the students, and for the people that are new and want to do the full course, that should hopefully, I'm really hoping for Monday. I really am. If I've had to cancel the last couple of Mondays just because I've been too sick to create the content, so I'm hoping that I'm getting better, so I'm hoping that continues. Anyway, have a nice. Um, do we have OOP? Okay, so for the people that are in my course, you don't really have to do the Monday streams. That's for your review purposes. You can be here on Monday streams if you want, um, but you're not required to. The only required classes are on Wednesdays and Thursdays. I can't just make up and say, no, you're required to be here on Monday. You might even have a different course. That I can't do that. That's above my pay grade. What I can do is put an extra stream for free education and for review and say, hey, here's some review content. Or if you're new to the stream, then here's some new content for you, an OOP course from day one going on, because I wanted to do educational streams for a while, and they seem to be my most popular streams, which is good. I've been wanting to do some free education stuff for a long time. Eventually, I'll get into maybe after the Christmas break or whatever, I might be getting back into synthesizer stuff and do some educational content on those. But for now, it's just OOP content because it's the easiest for me to create and because I'm doing the course currently. But no, you do not, if you are in my course right now, you are not required to be here on Mondays. That is just for review purposes and for people that want free education. On Mondays, I will be doing from day one what the course was. Most of it will be complete review until you get to like, chapter 5 or whatever, right? For Wednesday and Thursday next week, that would be about the logic of behaviors, where we start to look at these if statements more in detail, where we start to look at switches in detail. And then the week after, we'll start to look at loops in detail. And the week after that, we'll be looking for advanced relationships. And then we'll finally finish it all up with file handling and then the asynchronous programming. That's the way the course is going to go. I just haven't written it out in ACE-Learning, which I need to do. But yeah, okay. So I think that pretty much covers what I wanted to cover. Hopefully you enjoyed. Hopefully you understood. Again, this might be some of the code, like the while loops that you haven't done before, might be more advanced. But we're going to go over that starting next week with the if statements. Then we'll go over the week after with the while loops and the for loops and for each loops and all that. I might do some more advanced programming. I probably will do a lot of courses. So if you want to stick with me and take some more courses through me, I will probably be doing a lot of online stuff. But we're trying to figure out how it all works with DSB doing the train tracks the way they're doing, causing everything to be late and me, having issues getting there. Anyway, I hope you enjoy. I will see you next time on. I will have a stream on Monday, but you don't have to be there. I will not have a stream Wednesday. I will be in person. And Thursday, I will have only exercises. So it's going to be Wednesdays where I'm in person since I can be there for one day where they'll put me up in a hotel. And Thursday, I will just have exercises with the instructors for you to be there for those. So Wednesday lecture, Thursday and exercises, Wednesday lecture, Thursday exercises. That's what's going to be. And Monday review for the people that want to join then. Cool? Cool, cool, cool. All right. Enjoy the rest of your day, night, afternoon, whenever you're watching this, or even weekend. I don't even know. See you. Bye bye.